Okay, in the first two sections, we learned about our symbols and how to translate between symbols, words to symbols. And now that we know how to do that, we're going to start talking about truth. When is a statement true and when is it false? So when we talk about true or false, that's what we call the truth value of a statement. So the truth value of a statement is just classifying the statement as either true or false. Now, sometimes we know when a statement is true or false, but sometimes we don't. So oftentimes it's helpful for us to construct what we call a truth table. Let's look at a simple example. We'll start with negation, and then we'll do the ands and the ors, the conjunction, disjunction in this section. And then in 3.4, we'll move on to the conditional and the biconditional. Our first statement, P, is I will visit California. Now I want to figure out if I will not visit California, if that's true or false. So symbolically, I will not visit California is, oops, I want blue, is not P. So when is not P true and when is not P false? Well, that depends on P. And this is where we're going to construct our truth table for a negation. Let's say that P is true. Let's say that I'm going to visit California. So when I look at the statement, I will not visit California, clearly that's false. Well, let's say it's false. Let's say I'm not planning to visit California. Then the statement, I will not visit California, is true. So remember what a negation says. It says if a statement is true and you negate it, it's false. If a statement is false and you negate it, it's true. So let's build up. Let's look at our conjunction, an and I'm going to use I will visit California as my statement P. Q, I will visit Oregon. So when is the statement I will visit California and Oregon? When is that true and when is that false? Well, first of all, symbolically, this is an and. I will visit California is P and Oregon. So I will visit California and I will visit Oregon. So this would be a Q. I want to figure out when the statement P and Q is true and when it's false. So I need to look at all the possibilities for both P and Q. In the first row, it could be possible that P is true, Q is true. So let's think about it. Let's say I'm going to visit California and I'm also going to visit Oregon. So when I look at the compound statement, I will visit California and Oregon, that is true. But what if I have a true false? And here again, I'm working along the rows of my table. Let's say it's true that I will visit California, but I'm not going to visit Oregon. So the statement, I will visit California and Oregon, is false. Well, let's switch it around. Let's do a false true. Let's say I'm not going to visit California, but I'm going to visit Oregon. So the statement, I will visit California and Oregon, is false. What if I have a false false? I'm not going to visit California. I'm not going to visit Oregon. So the statement, I will visit California and Oregon, is clearly false. So I've gotten all possible combinations of true and false for my statements PQ. And then working along the rows, that will give me the truth value for P and Q. Something to note in an and is it's only true if both sides are true. If the original simple statements are true, then the and is true. Otherwise, it's always going to be false. Now let's look at a disjunction and or. Again, I have the same statements P, I will visit California, Q, I will visit Oregon. So I want to determine when I will visit California or Oregon, when that's true or false. Remember, the or is an inclusive or. So if I visit both California and Oregon, that will still make this or statement true. So symbolically, this is P or Q. When is that true? When is that false? I'm going to go back to our previous table. And to figure out all the possible truth values for two statements, it's going to become automatic here. It's easiest if you just let two statements. So P is going to be true, true, false, false. And Q I'm going to alternate as true, false, true, false. So if we fill it in this order, we get all possible combinations of true and false. Now you don't have to do it in this order, but it's typically the easiest way because then it becomes mechanical after a while. So this is an or statement. Let's say we have a true, true. I'm going to visit California and I'm also going to visit Oregon. So the statement I will visit California or Oregon is true because it's an inclusive or. It includes the possibility that both are true. Let's say I have a true false. Gonna visit California, not gonna visit Oregon. So the statement I will visit California or Oregon, true. False true, not gonna visit California, gonna visit Oregon. So the statement I will visit California or Oregon is still true. False false, I'm not gonna visit California, I'm not gonna visit Oregon. So the statement I will visit California or Oregon is false. So an or is typically opposite of an and. It's always true except in the one case where both sides are false. If both sides of an or statement are false, then the statement is false. In example 1, we have two statements. Now they're written symbolically. Our statement P is 4 minus 5 is equal to 1, but I could write it out in words if I chose to. And Q is 3 times 8 is equal to 24. Well, I don't have to fill out a truth table here because I know that P is false. So I'm going to put an F next to P because 4 minus 5 is negative 1, not positive 1. And I know Q is true. 3 times 8 is equal to 24 is a true statement. So parts A, B, C, and D is looking at the compound statements. In A, I'm looking at P and Q. Well, I know that P is false and Q is true. So if I just go back to my and I look at the row where I have a false true, I can see that that and statement is false. When you know the truth value for statements, you don't have to fill out a truth table. What you can do instead is just replace the truth value for the letters. So P is false, so I'm going to replace P with F. And Q is true, so I'm going to replace Q with T. So again, going back to that table, a false true is false. So that would be the truth value for the statement P and Q. Part B, P and not Q. I know that P is false, and I have a negation here, Q is true. So I don't have a table that has F not T. I just have FT. In this case, I want to simplify this further. I know that a not true is going to be false because I'm negating true. So this becomes false and false. Going back to our and false in an and is false. C and D, those are or statements. C is not P or Q. So not P is false or Q is true. So I have a not false or true. Simplify the not false to a true or true. Going back to your or, true or true is true. So this becomes true. And then part D would be not P or not Q, so not false or not true. A not false becomes a true or not true becomes a false, and this is an or, true, false, and an or is true. So again, if you do know the truth value for your statements P, Q, R, S, and so on, you can always just substitute F for false, T for true into your statement and then simplify till you get down to your simple statements and you can look at your truth table. In our last example, we knew the truth value of our statements, but let's say that we don't know whether our statements are true or false. In this case, what you want to do is you want to construct a truth table so that you can find all possible cases where your statement is true or false. So when we are constructing a truth table, what we want to do is we want to follow the order of operations, meaning if you do have parentheses or brackets, then you would do those first. After that, you work your way out. So you work your way from the inside out. If there are no parentheses or brackets, then you're going to work from right to or left to right as you read. Example 2, we're constructing a truth table for the negation of in parentheses P or Q. So notice I have two different statements P, Q, two different letters. So I want to list those. Oops, not like that. I have P, I have Q. All possible combinations of true and false. Well, for P, it would be a true, true, false, false. Q would be true, false, true, false. Now I'm going to work within the parentheses first, P or Q. And it's an or statement. So true, true is true. True, false is true. False, true is true. False, false is false. And then the last thing I want to do is I want to negate P or Q. So notice I'm not looking at P, I'm not looking at Q. What I'm looking at is this column here, P or Q. And then I'm going to negate that in the last column. So if this column is true, 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 false, then I negate it, it becomes a false, 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 true. Now notice this is the truth table for any statements P and Q. See if it makes sense. Make up a statement, a simple statement for P and one for Q. Like it is raining, it is sunny. And then look at the negation of in parentheses P or Q and see if the truth values of false, 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 true make sense. So notice that this particular statement is only true when both P and Q are false. So that would be this last row here. We'll do another example. In example 3, we have not P and not Q. Two different letters, P, always do that, P, Q. P is true, true, false, false. Q, true, false, true, false. So my goal is to have not P and not Q. But I don't have a not P listed in my table. I don't have a not Q. So I need to figure out what not P is and not Q is before I can figure out the and of not P and not Q. Looking at the column for the P values, if P is true, true, false, false, then not P has to be the opposite, false, false, true, true. And if Q is true, false, true, false, not Q is, oops, not Q is false, true, false, true. So we're going to put these together. Remember, we're looking at this as being the AND statement. So in an AND statement, if we have false, false, it's false. False, true is false. True, false is false. True, true is true. So for this particular example, this statement, not P and not Q, is only true when P and Q are both false. Why don't we do one more example? Example 4, we want to construct a truth table for, in parentheses, P or not Q or not P. A little bit more complicated, but the idea is the same. Start small. Work within your parentheses. P or not Q. I need to figure out that first. Notice that I only have two different letters, P and Q. So this should become automatic. True, true, false, false. True, false, true, false. If I wanted to figure out P or not Q, I don't have a not Q listed. So I need to figure out what that is first before I can do P or not Q. So remember, build up. So if Q is true, false, true, false, not Q would be a false, true, false, true. Now my or, P or not Q, I'm looking at the first column with P, third with not Q. Since it's an or, and it might be easier to see if I highlight this, true, true, or true, false, sorry, in an or is true. True, true is true. False, false is false. False, true is true. So this becomes true, true, false, true. Before I can figure out my complete compound statement, which would be parentheses P or not Q or not P, I need not P. Notice that's not listed. I have P, but I don't have not P. So I need to figure out what not P is first. If P is true, true, false, false, not P would be false, false, true, true. So I have both sides of my or statement. On one side I have, and I'm just going to cross these out. On one side I have the P or not Q. On the other side I have not P. It's an or. If we go from true to false in an or, that's true. True, false is true. False, true, 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 true is true. It turns out in this particular case, it's always true. So rarely does that happen. Do you always get a true or always a false? And that's the case we're going to look at next. So really the purpose of this section when we're determining truth is to get used to using truth tables. And it's going to be true in this section and the next section. The focus is going to be on the mechanics of learning how to complete truth tables. We're going to look at a very simple example. In this example, where it says construct a truth table for P or not P, notice that this is just one simple statement, P, and it's possible that P can be true or false. So my goal is to get P or not P. I don't have not P, so I need to figure out what that is first. So if P is true, false, not P would be false, true. And now when we look at this or statement, P or not P, we're looking at true, false is true, false, true is true. In the case where a statement is always true, we call that a tautology. And the previous example we had, that last column was all true. That's an example of a tautology as well. What happens if we change that statement from an or to an and? So again, notice we just have one simple statement, P, which can be true or false. I need to figure out not P before I could figure out P and not P. So if P is true, false, then not P is false, true. And then when we look at this and, true and false is false, false and true is false. In this particular case, our statement is always false. Doesn't matter if P is true or P is false. P and not P is always false. In the case when a statement is always false, that's what we call a self-contradiction. Statements are either tautologies, self-contradictions, or neither. Example 5, we have a statement. We want to construct our truth table. I have P and Q, so 2. P, true, true, false, false. Q is true, false, true, false. Notice that I have grouping symbols here, so I have to start there first. And in fact, where I start is the innermost parentheses, P and not Q. P is already listed. Not Q, I don't have that. So I need to figure out what not Q is first before I could figure out P and not Q. So if Q is true, false, true, false, not Q is false, true, false, true. And then when we put this together, we're looking at P and not Q. This is an and statement. So true, false is false. True, true is true. False, false is false. False, true is false. So this becomes false, true, false, false. Looking back at our statement, we know P and not Q. So now we're still working in our grouping symbols, this time the brackets. I now need end P. Okay, so notice that P is already listed, so that's not an issue. I need P and not Q, which I already have, and P. This time I'm looking at the statement we just had, P and not Q, and the first column with P. Luckily, with an and statement, the order doesn't matter. So this is an and with false, true, which is false, true, true, which is true, false, false, which is false, 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 which is false. So this is going to be false, true, false, false. We're done with the bracket. Now we can do our whole statement, which is the bracket with P and not Q, and P, close bracket, or Q. I'll use red. So on this one, I'm looking at, and in fact, I think I'm just going to get rid of all this stuff. I'm looking at this column with Q on one side of my OR, and then the last statement we did. So again, the order doesn't matter because it's an OR. But if I were going in order, it would be a false, true, but it's an OR. So false, true is true. True, false is true. False, true is going to be true. The last one is false, false. So that's the only column that's going to be false. And we have true, 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 false. When I look at that, I can see that it's not a tautology, it's not all true, it's not a self-contradiction, it's not all false. So in this case, this would be neither tautology nor a self-contradiction. We haven't really talked about this yet. What happens if you have more than two statements? Well, we have seen, and I'm going to go all the way back to the top of this page, we've seen that when you have one statement, that there's two rows. So the amount of rows, it turns out that that's going to be equal to 2 to the n power. And n is going to be the number of, I'll just say letters, different letters, right? So in the case of P or not P, P and not P, there's just one statement. So in this case, our n is 1. So there's going to be 2 to the 1, or 2 rows. And when I talk about rows, I'm not talking about the top row. I'm talking about the rows of trues and false. In example 5, we have 2 different letters, P, Q. So there's 2 to the second power, or 4 rows. So what happens when you have 3 letters? In this case, example 6, I have a P. Oops, I want it to be blue. I like blue. I have a P, I have a Q, and I have an R. So I'm going to have 2 to the 3 different letters, which is not 6, right? It's 2 times 2 times 2, which would be 8 rows. So if you know how many rows there are, now think about this. We have to figure out in our first column all the different combinations of true and false for 3 statements. So the way we do that is we know how many rows we need. We first cut the rows in half. So that would be 4 and 4. So for P, I'm going to have 4, 1, 2, 3, 4 trues, and then 4 false. Again, you don't have to follow this pattern, but it becomes mechanical, it becomes really easy to do. So now we're going to cut 4 and 4 in half to get 2's. Q is going to be 2 trues, 2 false. 2 trues, 2 false. And now that we did 2, 2, 2, 2, we're going to cut that in half and do 1's. So true, false for R. And if I follow this pattern when I'm creating my truth tables, I've gotten every combination of true and false for the 3 statements. Going back to the statement, I'm supposed to figure out P and not Q, and R and Q. Working from the inside out, I have to do the parenthesis first, so this is very similar to the previous problem, except for now we have 3 statements. Notice that I don't have a not Q, so I need to figure out what not Q is first. So looking at the column Q, it's true, true, false, false, true, true, false, false. Not Q would be false, false, true, true, false, false, true, true. Now I could figure out what P and not Q would be. And remember, it's an and. So when I look at P and not Q, and I look at this and, it's a true, false. So true, false is false. And then true, false is false. True, true is true. True, true is true. And the rest should all be false. Because remember, when you have an and statement, if one side is false, the whole thing is false. And I could see that P would be false, 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 false. So already I know that this is all going to be false. Going back to my statement, I'm now going to do the working in the bracket, do the and R. So P and not Q and R. So notice that R is already here. I'm not doing these columns, these two columns. I'm looking at the P and not Q on one side of my and the R on the other side of my and. So this is going to be a true false, or actually a false true if you go in that order, but since it's an and, order doesn't matter. But if you were, it would be false and true, which is false. False, false is false. True, true is true. True, false is false. False, true is false. False, false, false. False, true, false. False, false is false. So looking at this, it's going to be false, false. Only one true here. The rest will be false. Okay. Now I can finish this up. I know what the bracket is. The P and not Q and R. And now I need an and Q. Sometimes when you're working with truth tables and they get really large, it may be helpful to just write down real small what the values are. I think I'm going to change the color. I'm going to look at our last column and Q. Notice that this column is, so real tiny, I'm going to write false, false, true, false, 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 which is okay. And then the Q goes true, true, false, false. So true, true, false, false. You don't have to do this. True, true, false, false. But sometimes it's hard to keep track of what you're looking at. So now that I sort of wrote this down real small, I can see that with this and, I have a false, true is false, false, true is false, true, false is false, 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 true, false, true, false, false, and false, false. I could see that this is all false, so this would be the case of a self-contradiction. Okay, in example 7, we're going to construct a truth table for this statement. I study hard and ace the final, or I fail the course. So that's part A. And then part B, suppose that you do not study hard, you ace the final, and you fail the course. Under these conditions, is a compound statement in part A true or false? So to solve this, since we're given a statement in words, not in symbols, we have to first label our simple statements and then express the statement in blue symbolically. Once we have it written symbolically, we can construct our truth table. Let's go back to our statement and identify our connectives. I study hard and ace the final, or I fail the course. Remember, there's a comma there. So I'm going to let P be the statement I study hard. So that would be in the first set of parentheses that I just wrote up. P, I study hard. So this would be my labeling of my simple statements. Ace the final is not a statement. So for Q, I have to write I ace the final. So remember, it has to be a complete sentence. And then I fail the course could be R. Now that I've identified my simple statements, I can translate this. This is P and R or P and Q, sorry, and P and Q or R. I have two connectives. I need to put in my grouping symbols, but since I do have a comma, I know that P and Q are grouped together. Now this statement is going to be in parentheses P and Q or R. Whenever you're going from words to symbols, you do have to identify your statements because then your letters make no sense. If you don't identify your statements by assigning P, Q, R, and so on, then once you put it in symbolic form, it makes no sense. So anytime you, in mathematics, anytime you introduce a variable, you should identify it. I have three statements, P, Q, and R, which means I need 8 rows. The first 4 in P would be trues, 4 trues, and then 4 false. Q, 2 and 2, so 2 trues, 2 false, 2 trues, 2 false. And then R, I'm going to alternate true, false, true, false, true, false, true, false. In the parentheses, I have P and Q. I need to do that first. So I'm looking at the first 2 columns, P and Q, and it's an and. So it's going to go true, true, but the rest are going to be all false. So now the final statement, parentheses, P and Q or R. So again, I'm doing P and Q, and then I have R. It's an or statement, so true, true is true. True, false is true. False, true is true. False, false. I have a false there. True, false, true, false. Okay, so we completed part A. Oops. We constructed a truth table. Now part B says, suppose that you do not study hard, you ace the final, and you fail the course. Under these conditions, is the compound statement in part A true or false? Okay, so that means we're looking for a particular row. If you do not study hard, then I study hard is false. You ace the final, I ace the final is true. You fail the course, I fail the course is true. So I'm just looking for that particular row that goes false, true, true. In that row, the value of the statement is true. So is the compound statement in part A true or false? We looked at the appropriate row and we found that it was true. Notice that in this problem, I really didn't have to construct a truth table. I could have still identified my statements and looked at the symbolic form, which was P and Q, or R. And I knew that P was true, or false, sorry. And Q is true, or R was true. So since I knew the truth values for P, Q, and R, I didn't have to do a truth table, but it was in the instructions, so I did one anyway. And then I would just simplify. Looking in the parentheses, false and true. It's an and statement, so that's false. And I still have this or true on the outside. And then false or true is true. And that's it for this section. The next section, we're going to explore the truth tables for the conditional and the biconditional.